what device you want to give me to connect 80 to connect with 80851. So the device is very important. The whether the device is LCD, whether the device is LED, whether the device is switch, or whether the device is keyboard, you must have some basic for these device. Then only you can connect this device with the 8051 microcontroller. Yes, this is clear to all of you. This first point is clear. You will not bother about any device. Yes, give me any device. Just I should know the concept or the some features of those device. Then only it is possible for me to connect those device. Now coming to the LCD interfacing, we know LCD come with 16 cross 1, 16 cross 2, 20 cross 4. So now first of all, tell me how many rows are there in case of what type of LCD you are giving me to connect this one. So ideally or mostly the used LCD configuration is 16 cross 2. So this device they want you to connect. So either this is the device is given to you. Now see, this is the two rows and each line having 16 character. We all know. Now there are so many pins associated with this LCD. What are those pins, sir? There are so many pins associated with this, sir. So I'm just going to tell you those ones, sir. First of all, there are 8 pins from D0 to D7 in the LCD, as well as there is one another pin to select the register, that is register select pin. Then one is pin is basically read and write pin associated with the LCD. And the third pin is the enable pin is associated with the LCD. And the fourth pin, this pin is basically VCC. That means VCC, we have to give some power supply to your LCD. And then the last one is the VSS, that means the ground. These are the pin we must know. That means these are the pin required to be connected to the microcontroller. Then only your microcontroller will be communicating with your LCD device. Okay, sir. Now we know this, sir. First of all, then we will design. We will choose one microcontroller as well as then we will choose one microcontroller. This is suppose this is the microcontroller, and then we'll be talking about this LCD. So we know, sir, this is an LCD. Suppose this is an LCD, and this is our 8051 microcontroller. So we all know the basics of microcontroller. The microcontroller have 4 ports. So out of those ports, I am interested in because we need only this much pin in our use. See, these 8 pins we want to use. So this will be done by connecting with the port. Suppose port 2. So now the port number 2, all the 8 pins from all the 8 pins are basically connected to the D0 to D7. This is P2.0 to P2.7. These pins are microcontrollers are connected directly with the D0 to D7 pin. Now the job of this has been done. Okay, sir. Now these 3 pins are used from the port number 1. We can use from the port number 1. That means port number 1.0, port number 1.21, and the port number 1.2. These pins are basically used from the port number 1. This pin is used for the connecting the RS. This pin is used for connecting the read and write. This pin is basically used for enabling the signal. That's it. Rest of the port is unused. That means port number 1 and the port number 1 or port number 0 and port number 3 is unused. Here in this application, these are unused. Not a problem, sir. And out of this port number 1 also 1 to that means 3 to port number 1.47 bits are also unused. So we will connect those pin with the ground. This is also connected with the ground because these are unused pin. We don't require this pin to be used in our use because LCD in the LCD, these are the pin which we will focus on. These 8 pins are directly connected to the port number 2. These 3 pins are using the port number 1, bit number 0, 1 and 2. And there is another pin that is VCC. This VCC that 5 volt is connected to this pin. And then there was one another pin VSS that is ground basically given to the ground. That's it. So this is the connection. That means every time what we will do, we will look at this LCD or the device. This is basically device. We will look at the device. How many pins are there in that device? You need to be connected to the port. And that pin is basically connected to the microcontroller pins. And depending upon the operation, we will follow. Now, we have also seen this others. That means in this case, we have to first, which is very important, sir. first of all, it is very important to activate. Oh, sorry. It is very important, first of all, to select. That means when we are connecting an LCD, sir, na? So in the case of an LCD, it is very important to first of all select the LCD. So in order to select the LCD first, we have to send one command to the LCD from the port number 2 only. So in order to select the LCD, we have to send a command. The value of those command is basically 38H. This command need to be sent inside the LCD from the microcontroller port number 2 to select the LCD. Okay. Now, again, after selecting, we need to, after selection of LCD, we need to on the LCD display. So in order to on the display, we need to send a command inside the LCD. The command is basically 0F to initiate the or on the display or the on the cursor. So this is basically 0F, which is the command that this command should be loaded into the accumulator. And this accumulator content will go to the port number 2. And then from port number 2, this will be going to the LCD. Good. This is the command. This command will be loaded into the accumulator, and this accumulator content will go to the port number 2. And from that port number 2, it will be sent to the LCD. So this is the command. This is the flow of the data. This command will first of all will be loaded into the accumulator, and from that accumulator it will be going to the port number 2, and then from port number 2 this will be going to the LCD, and this will be going to the LCD. Okay, and this is very important. And the third is that, sir, the third point is that we have to move another one command. This is 01. This will basically clear the display or LCD. Okay, the same procedure will be going on. This will be loaded into the A, and then A will be loaded into the port number 2, and then this will be from port number 2, it will be transferred to LCD. Same. Now the fourth one is that we have to use this 06 command to cursor, make the cursor increment from left to right. Same, this will be moved to the accumulator. From that accumulator, it will go to the port number 2. From port number 2, it will move to the LCD. Now the fifth and the last one is that the command is ATH. This command will basically again move to the accumulator. From that accumulator, it will move to the port number 2. From the port number 2, it will be going to the LCD. Now, again, the meaning of this cursor, this command is that home cursor. That means the cursor will be on the line number 1 and the position number 1. Okay, this is the meaning. So after moving this command inside the LCD, what happens? What happens? Our LCD becomes one. Now LCD is selected. This will be on. And then after that, the cursor will be incremented one from left to right and all this processing. And then now the task is basically to send the data. So now to send the data, simple procedure as we are sending the command, we have to send the data. So what data you want to send, you can send, but remember that from port to LCD, remember that in this case, you want to send a data, from the port number 2 to LCD. So in that case, you need to select the RS value is equal to 0. In this case, you need to select the RS value is equal to 0. In this case also, you need to select the RS value 0 because you are moving the command into the command register. So you need to select the command register. But here, when you are transferring the data now, all the procedure will be same. That means data, whatever data you want to send, that data will go to the accumulator. And from that accumulator, this will be moved to the port number 2. And from that port number 2, this will go to the LCD. But the only thing is that while transferring this port number 2 to information to LCD, the only thing is that RS will be selected as 1. And this will be done by using an port number 1, bit number 1 to set. We have to set this bit by 1. In this case, we have to clear this port number 1.1 because we need to set the RS value is equal to 0. This is the only thing different. This is the approach we are following, sir. While sending the data, while receiving the data, this is basically we are doing. So now, sir, the only thing is that now we will be coming to the very important discussion, and I will show you today also because very, very interesting are these programmings are because the boring part was over. The information part was over. Now we are going to the application part. Now it will be very much interesting, and I will show you that also, sir. Then again, what we have started right in our program. In the program, first of all, what we are doing, we are initializing the program. That means org. Earlier, we are using every time 000x. We can write anything, and this the meaning of this that you want to start your program from 000h, or you want to start from your program from any location. So suppose you have started your program to this one, these lines are assembler directive. Now after that you are writing a very beautiful that is defined byte, and then you are comma, you are writing deep bracket, and then you are writing 1, 2, 3, and 4. Okay, you are sending alphanumeric message. You want to send alphanumeric message to your LCD. Good, no problem. As soon as you will write these two lines now, your assembler will do this task. Your assembler will go to the memory location, and now your assembler will go to the memory location, and it will reserve an space. It will start reserving an space. Look carefully. Okay, so your assembler will start locating from this is 0000, this will be 0001, this will be 002, this will be 0003, and this will be 0004, and this will be 0005, this will be 0006, this will be 0007, and so on. This will be 8, and this will be 9, and this will be 8. Now, see, this is very important. Sir, how many characters? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so here the content will be saved D E E P space 1, 2, 3, 4, 5. Sorry, this will be now. Look careful, sir. So be careful in this case, sir. No, you are wrong, sir. This will not store D. Wrong. This will not store D. Wrong. This will not store E. Wrong. Everything is you have written is wrong, because you told us in the 8086 concept, whenever you press anything on the keyboard, ideally speaking, this this is not basically going to store, but instead of this, what is going to be stored? And instead of this, basically you are ASCII code of this letter is going to be communicated within your microcontroller. So as soon as you press D now, corresponding to that ASCII code will be saved at this location. Okay, good. Now corresponding to this ASCII code will be stored here. That means instead of D, E, and P, and now whenever you press this letter, now is there ASCII code will be going to be at those locations. And I will show this also in the programming of Kill software. I will show you what are the ASCII code. If you remember in my previous class, ASCII code for 1, 2, 3, 4, 5, 6. If you remember, what is this will be 01, this will be 2, 02, this will be 03, this will be 04, and so on. If you remember, this is not 01 for 1, they are storing 31. You remember 30, 31H, 32H, 33H, and so on. If you remember these things, when you press 1 now, instead of 1, it is basically storing 30H. This is the ASCII code for 1. Remember or not? Please tell me. Remember in the programming part,
Yes,
when
sir.
you are
Yes, sir.
subtracting 30, adding 30, remember? So that means when you press 1 now, the ASCII code for is 30H. So we need not to remember this ASCII code. I will tell you, I will show you how to see this. So that means this is the approach, sir. And then we will start writing program. When we will write two subroutine program, one is for command and the another one is for data. Subroutine from the command and data is similar. Only thing is that we have to that set the RS bit 1 or 0. That's it. Whether you are sending data and command, and the rest of the program will be same. Now, sir, please show these things. Whatever you are telling now, please can you show these things on the Keel software? Yes, I will show you these things on the Keel software. Then you will feel
Yes,
visible
sir.
to.
Yes, sir.
Okay.
It's
Now,
visible.
if the screen is visible, so I'm just going to delete everything. I'm just going to written in the previous class. I have written some program, if you remember, and I have sent those program to also interfacing of LCD. So I'm just copying those, copy paste these things in the Keel software instead of writing, because it will save my time. So see, everything is written. Now, if you look carefully, sir, we look carefully, sir. If you look carefully, this one from where the program is started, please tell me. Please tell me, program is starting from the location 0500, yes or no? Please tell me. Yes or no, at least. Hello. Starting from 0. So that means at 500 location, 1 is the story. Okay. At 500, 501, 2, 503, 3. Now we want to see these things also, sir. Can you show this? Yes, I will show you. Just I'm going to execute this program. Let me try this. This is, sorry. See. Okay, now I'm going to first of all see whether there is no error. See, no error. I'm just going to build this program. Now I'm going to run this program. Have a look. After running this program, what will happen? Okay, now this is very important. I'm going to execute this program also. See, I'm going to run this program as a whole. Now have a look. Can you want to see what is happening? So we are interested in the location of 0500. You are telling that from 0500, ASCII code for 1, 2, 3, 4, 5, 6, 7 and A will be stored, or 1, 2, 3, 4, 5 is basically stored at this location. I want to see that. See, I'm just writing this and pressing enter. See. If you look carefully, sir, what is stored at this location, sir? Instead of 1, 31 was written. Instead of 2, 32 was written. Instead of 3, 33 years were written. 4, 5, and 6. C. Getting? Now have a look. So after 9, for A, 40 is not coming, 41 was there. If you remember in my previous class, that means from 0 to 9, 30, 31, 32, 39, and from A to F, 41, 42, 43, 45 was stored. So now, sir, this is clear from here. These are the ASCII codes. See, as soon as you will write this, now, sir, I want to remove this. Instead of writing A, B, C, D, so I'm just going to write, instead of writing 1, 2, 3, I'm going to write A, B, C, D, A, B, C, D, E, F. So we want to see the ASCII code of this will be 41, 42, 43, 44, 45, so on. So I want to see whether these things are basically happening here or not. So I'm just going to execute it once more time for you all. Have a look. I'm going to build this. Now I'm going to execute this program. After executing this program, I'm going to run this program. Please run this program and have a look. Please look at the addresses from this now. Instead of A, 41, instead of B, 42, 43, 44, 45, and 46. If you remember, for F, 46 was there. Sir, that means whatever type, whatever message you want to send now, that message will be showed on your LCD screen. But when you are writing this instructs, instead of this, these basically getting stored. So now I want to see this is starting from 5000. Sir, but we don't want to start this program from this location. Please remember this later, 41, 42, and 41. I want to start this program, sir, from the location 0300. We don't want to start our program from the location 0300, but we are interested in this program to be start from 0300. So now we want to see whether this Skype code of this will be going to this location or not. Please show me that. So now in order to show this, I am again going to execute this program, run, build, and then execute. See, at last whole program will be executed. Now I'm going to execute this whole program. See, now have a look. Sir, at this location, at this address, what are the contents, sir? At this, the content is 000. Nothing was there. So we want to see the content on 0300H. We want to see this content of this. See, have a look. Now whole content is moved from 30, 41, 42, 43, 44, and 46. Have a look. Now, is it clear to all of you how these things are going on inside this? So whatever you message you type here now, it basically not up to you. You do not know to the ASCII code of that. Yes, whatever you write, ASCII code will be saved at that location. It's starting from 300. That's it. If you want to change your program starting from 000, we can do this, sir. From 000, we want to start the program. Start the program from 00. Not a big deal, sir. We will start this program from 000, and then we will execute this program, run this program, then execute this program. So now we will be executing this program. Come run this program. Now see, from the location 300, everything is gone. Now this will be coming at the location 0000H. See, now we want to see. Now we will be interesting. Now is it interesting? Now you can visualize everything. Yes or no? Please tell me.
Yes, sir. Yes, sir.
Okay. Okay, so if this is clear, sir, now, so now everything is clear. The program of LCD is very, very easy. Oh, sorry, LED we remember is this one, sir. In case of an, I'm just going to compare LED switch and LED, so you will be able comfortable enough. See, so suppose this is an LCD, so this is an LED, this is a switch. Okay, now have a look. We will be comparing and you will see how easy is it. LCD, sir, LED, sir. Now, this is switch, sir. Okay, sir. No problem, sir. Inside this LCD, this is basically suppose two. This screen is there, 16 cross 2. So this is 16 cross 2 screen. Okay. So internally, there how many pins are required to send some data or command? We need a pin from D0 to D7. Okay. Now, in order to communicate which data you want to communicate, we are interested in RS, we are interested in enable pin, we are interested in read write pin, this pin. And then other than that, we need plus 5 volt supply. And other than that, we need an VSS, that is ground pin. That's it. Now, these which pin are required to communicate with the LCD. But if you look at the LED and switch, so only one pin is required. That means VSS. That means this pin is basically ground. In this case, also only one pin we are interested. That is VCC is equal to ground, and the rest one pin is basically used. See, this pin is basically used. This is pin is basically used. This is we count the output, or we can say that anything. This is basically one pin is required. That means output pin. We can say that. That's it. That means this mean in this case only this pin is important. Only one pin is important. If only one pin is important. So if there is anything, suppose if there is one here, so the LED will glow. If the air is zero, the LED will be off. So that means very simple, sir. Only one bit is required. Only one pin is required. If on that pin, if the data is one, so that means the LED is on. If there is zero coming on that pin, the LED will be off. Similarly, if there is a one there, so the switch will be on. And if there is one zero, then the switch will be off. See how simple is this. So instead of this much pin, because these pins are required to on the LED or LCD, but here it is not required. So no pin is required, only one pin is required, sir. So this is very simple, sir. So out of four port 0, port 1, port 2, and port 3, in this case, port number 2 was used for this connection because all 7 pins are used. And out of this port number 1, 3 pins are basically used here. And these pins are unused. These pins are used unused. And so this now, if you talk about here, sir, here also we have P0, P1, P2, and P3. Sir, here also we don't require this. We don't require this. We don't require this. But here only thing we required port number 2, and in this port number 2 only we require only one bit. Either you can use port number bit number 0, or you can use port number 2 port number bit number 1, or you can use port number 2 bit number 3, so on. That means here it is required only one port, and out of this port only one bit is required to connect to this microcontroller. So interfacing of LED with the microcontroller is very simple, sir. We can connect anywhere with the port number 2. We can connect on the port number 2, bit number 0. We can connect on the port number 2, bit number 1, and so on. Similarly, we switch is there. Is it clear to all of you? Is it clear? Yes or no?
Yes, sir.
Interfacing of
Yes,
LED
sir.
is easy or tough?
Yes, sir.
Is it easy or tough? Interfacing of LED and switch. Tell me yes or
I
no.
think it will be easy.
Okay, now have a look. So this is very easy, sir. So because only one pin is required, the only thing is that in this case, we want to now the program. What we are interested, so we can connect any LED. So, sir, what you are doing now, you are generalizing the things. Okay, let me generalize this. Sir, this is 8051 microcontroller. So out of these port number 1, and port number 3, we will not be using. And I am interested in using the port number 2. The port number 2, point 0, port number 2, point 1, port number 2, port number 3, and so on up to port number 2. We are using port number 7. So we are interested in connecting one LED. I will connect with this port. One LED I want to connect with this port. one LED I want to connect with this port, one LED I want to connect with this port. So that means how many LEDs we can connect with this one port? We can connect 8 LEDs simultaneously with the one port. So now I am going to tell you the generalized program. I'm interested in tell you the generalized program. And if in the question it is asked to use 2 LED, if you went in the question it is asked 3 LED, you can use those. But I am going to give you the generalized solution for LED. That is, this is an LED of 8 LEDs. So all these LED can be connected to the port number 2 because there are eight pins now, and the rest and this part is basically connected where? So this LED is basically the other wind is basically connected to the ground. That's it. Now what happens, sir? If you look carefully, sir, if you look carefully, sir, if this is one, if this is one, if this is one, if this is one, that means port number, sorry, I'm just going to write here. So look at carefully. So the port number 2, bit number 7, port number 2, bit number 6 and 5, 4, 3, 2, 1, 0. So please do. This is the port number, all the bits. Now, suppose if there is one, sorry, 1. See, this is F. This is F. So that means if on the port number 2, if you send FF, what will happen? Sir, if you send on the port number 2, FF, what will happen? All the LED will be on. Yes or no? Please tell me. All the LED will be on when if you send on the port number 2, FF, if you send, what will happen? All the LED will be on. Okay, sir. You want to on only one LED, which is port. If you are out of these LED, you are interested in on the one LED, alternate LED. Okay, sir. If you want to on the alternate LED, 1, 0, 1, 0, 1, 0, 1, 0. See, what is this? This is A. And this is again A. So if you load in the port number 2, if you load in the port number 2, AA, what will happen? Alternate LED will glow. Getting these point, yes or no? That means it is very important how what value you want to load on the port number 2. It's very as simple as that. If you want to on the all LEDs, you can send this signal to port number 2. Okay, sir. And this is data only, sir. Remember that this is data, not command. Okay. Now, to off the LED, what will happen, sir? To off the LED, simple 0, 0, 0, 0, 0, 0, 0, 0. See, to off these LED, you have to load in the accumulator 0, 0, F. So if the first of all, what we will do, we will load this value directly into the accumulator, or we can directly send this value to the port number. So this is the ideal practice. First of all, this FF will be loaded into the accumulator. And from this accumulator value will be loaded into the port number 2. Then after that, we have to execute this some program. And that program is nothing but the delay program. Why? If you load FF into the accumulator and this accumulator content will be in the P2, what will happen? So this is mean you want to on the LED. At what time you want to on the LED and how much time you want to on the LED? This is called the delay. So for what time, what duration of time you want your LED to be on, you have to write a delay program here. Again, after loading 0, 0 into the A, and again this A into the port number 2, this means you want to off your LED up to how much time you want to off this LED. Again, you have to execute this program. That means this is called subroutine program delay. So that means ideally what is means, sir? Ideally is that if you write any program, what will be the program, sir? The program will be simple, sir. In order to on this LED, you have to write this move what value you want to move in the accumulator. In the accumulator, you have to move 0 F F F. If you remember, we cannot write FFH because we have to use a prefix after the FX. If this will give you an error if you write FFH. 0 FFH is same as FFH. The only thing is that it will give an error, syntax error in the programming code. So we will use a prefix 0 here. The meaning is same. We are loading FF into the accumulator. After this, we will have to move this content into the port number 2. So the accumulator content was now moved into the port number 2. Now, what happens? The 111 is basically, so 111 is there. So all the LED is glowing. How much time you want to glow this LED? So you have to call a function that is called delay subroutine. This will tell how much time you want to on the LED. Okay, sir. Now, after that, again, we have to off this LED. In order to off this LED, what we will do? We will load 00H, and then we will move this content into port number 2 from the accumulator. And then again, we have to call this function, what is called delay, because up to how much time you want to off this LED. Now, suppose you want to do this on and off. So what we'll have to do? We have to jump, that means sort jump to a position called back, and this position will be starting from here. So this is basically a back. So that means in order to do the blinking of LED on and off for some duration of time, and this some duration of time will be decided by this delay function, and this is basically now this will be decided by this function delay. So that means this program is basically for blinking of LED, 8 LEDs simultaneously. So now this 8 LED will glow for some duration of time, and it will again off for some duration of time. And what is the duration of time is basically decided by this delay subroutine program. Up to this clear or not? Then I will write a delay program. This is clear. Yes, interfacing of LED and writing the program, glowing the LED and of blink of the LED is clear. No, sir. Now we want to. This is basically for some duration of time I'm glowing the LED, and for some duration of time now. So we don't want to glow all the LED at a time. Let me make me very more interesting, sir. Now, sir, these are the LEDs. So 7, 6, 5, 4, 3, 2, 1, 0. So these are the LED. We want to glow all the LED. Yes, simultaneously. And then we want to turn on all the LEDs. Okay, sir. Then if you want to, you have to load first FFH, and then you have to load 0H. Okay, this value you have to load. Now, sir, we are not interested in this. We want to glow alternate LEDs. If you want to glow alternate LED, what you have to do? You have to do it like this. This program you have to load. That means AAH and then 00H you have to load. Okay, this will basically work. Now, sir, we want another thing. We want to glow first edged LED in one go, and then this will be off, and we want this again, this will glow, and in the upcoming cycle this will off. So that means what you want, sir? I want this on this all these 4 LED, and then this will be off at the same duration. I want this LED to be off, and then we want this LED to be on. So alternate. So for that, for this case, we have to load F0, and then we have to load 0F in the off button. So for this type of duration will be on, and for this time this LED will be on. So now this LED will flash, and then this will be off, and in the next cycle this will be off and this will be on. So depending upon the application, you can do anything. Now, sir, we are interested in only 3 LEDs. Suppose sir, we are interested in only 3 LED. So this is 7, this is 6, this is 5, this is 4, this is 3, this is 2. 1 and 0. We are interested in 3 LEDs, sir. So the first LED so I'm just calling it as a red LED, yellow LED, and suppose this is a green LED. Okay. So we are interested in only these 3 LEDs. We are not interested in these LEDs. Okay. If you're not interested in these LEDs, sir, so what value we have to know? So first of all, this will be 0 only, because we are not interested in this. We are interested in these only LED. So you want to grow which LED? Sir, I want to grow, suppose red. Suppose first of all, I want to grow a red LED. So this will be 1, and this will be 0 and 0. So you have to load this value. Okay. Now what we will do? Move a comma 0. What is this value? This is basically 8, and this is 0. So I will let 8 th, and then we will move this content into the port number 2, that this is an accumulator, and then up to how much time you want to glow this LED, red LED. So suppose you want to grow for this for the 10 millisecond. Okay. So now I will call delay and this delay subroutine will be providing a delay of 10 milliseconds. Suppose I will write delay program after that. Okay, sir. Good. Everything is okay. Now, sir, just after that, we don't want to, we want our yellow light to be glowed. Just after that, you want your yellow light to glow. Okay, then what is the meaning of this? That means this will become 0 and this will be 1 and this will be 0 and this will be 0 and 0 0 0. So just after that red light, you want to glow your yellow LED. In that case, just after that, you have to load 40. Okay, sir. Then we have to load move A as this will be 40H. Now this 40H will go into this move port number 2, and this is the basically accumulator. Again, up to how much, sir? Again, for 10 millisecond, I want to. Okay, no problem, sir. So this will again, I will call the same function. Suppose the program has been changed. Suppose they want you to glow this light for 10 millisecond, and suppose they want to glow this red light for the 1 second. So you have to change this subroutine program for this one. So this delay 1 is basically providing a delay of 10 millisecond. This we have to write another second subroutine program for delay 2, and this will provide a delay of 1 second and so on. Suppose you want to same millisecond delay, so we can use both the subroutine program here only. Okay, sir. Now, suppose after that, after this light, we want to glow another light. That means we want to glow our green light. So this will be off. This will be off. We want with this green light. This will be 0, 0, 0, and 0. So see what is the content. So 20. That means this is 20H. So now, so this is basically move. This is basically a move accumulator, and then this will be 20H. And now this content will go into the port number 2. This accumulator content will go to again up to what duration of time you want to glow this green light. So we want to glow this light for the duration 10 millisecond or 1 second. Okay, whatever be the case, if it is 10 millisecond, I will call delay 1. I will call delay 1 subroutine. If we want this light to glow for the 1 second, so we will call this subroutine delay 2. If we want to glow this light for 10 seconds, we can call subroutine 3. That's it. So that means depending upon this time, we have to write 3 different subroutine for delay. Suppose this is delay 1 subroutine, and this is for delay 2 subroutine, and this is delay 3 subroutine. This delay will provide 10 millisecond delay. This will provide 1 second, and this will provide 10 second, and this is 1 second. If suppose all the LED light you want to glow for same duration of time, so in that case you need only one delay subroutine. That's it. Is this point clear? Yes or no? Is there any difficulty or is there any confusion? Please tell me how to load, what to load. Is it clear?
Yes, sir.
Okay. Now coming to the last one, now it is only thing is left. So how to create a delay subroutine, how to write a delay subroutine, and what is the thing you are going to use. So we know to create a delay, we need a timer. Either you can use a timer 0, either you can use a timer 1. So now I'm going to use a timer 0 or timer 1 to create a delay. I want to create a delay for 10 milliseconds. I will write 2 subroutine program. One subroutine program I will write to create this delay for 10 milliseconds. One subroutine program I will write a program to create for delay of 1 second. So both the program will be same. So but I am going to create a delay subroutine. How to write a delay subroutine for the case. Now I am going to create this delay subroutine. This is a delay 1. This will create a delay of 10 millisecond. Okay, I'm going to write again a program that means delay subroutine 2. This will create a delay of 1 second. If you know this, how these two delay subroutine, you can write any delay subroutine. If you know this concept. Okay, sir. Now, in order to create a delay, we need a timer 0. We need timer 0 or timer 1. So we will be using our timer 0. For our case, we are using timer 0. You can use timer 1 also, not a big deal. So first of all, we will be using the timer 0. One thing is that in order to create a delay, we want your timer to be working in the mode number 1. Remember this. We want to choose any timer, and I want our timer to be working in the mode number 1. To create a delay, I want a timer to be working in the mode number 1. If you remember to work in the work in the transfer serial bit transfer, we need our timer to be working in the mode number 2. So remember this, if you want transferring serially some data, so mode number 2 is important. And if you are creating a delay, then we want our timer to be in the mode number 1. So now how to decide or how to set that your timer will be in the mode number 1 or 0. So for that, we all know very simple thing is that we have to write this program. This is the program I'm talking about. First of all, move. If you remember T mode, we have to load inside the T mode. What is value we are going to load? We have to load 0, 1. If you load 0, 1, this means you are selecting, you are using your mode to be in the mode number 1. So you are selecting your timer, and not only this mode 1, you are selecting your timer 0. So this is timer 0 and mode number 1. You have to load this data into the T mode register. As soon as you will do this, your timer will be selected. That means timer 0 will be selected. Not only 0 will be selected, it timer mode number 1 will be selected. Now remember that we have to set the timer to for the delay of 10 milliseconds. To create a delay of 10 milliseconds, we have to load something inside the timer. So I'm just going to load it there because we know the timer 0 is basically of 16 bit. We know timer 0 is of 16 bit. Out of this, one is called TH0 and one is called TL0. This is 8 bit and this is an 8 bit. So in order to create a delay of 10 millisecond, we have to load inside this TH. We have to load D, B, F, F, H. This value, if you load inside your timer 0, then it will create a delay of 10 milliseconds. So for that, we have to load. So we cannot load directly 16-bit data. We will add in two parts. That means TH0. I will load with the data 0DBH. Now again, we will load the data TL0, comma, what data we want to load? 0FFH. After loading this data into the timer 0, why you are loading in the timer 0? Because you have selected this timer 0 of timer 0. Now, as soon as you load this data into your timer, what will happen? This will be helpful in creating the delay of 10 millisecond, because this is basically what data you are loading in the 16-bit DBFF. DBFF means, sir, you are writing, suppose 16-bit data, all this will be F111, 111, and this will be B, that means 1011, and this is basically D. So that means this is 1010A, 1011B, 1100C, 1101 is basically 1101 is basically D. This is D and this is B. So it will goes on incrementing one by one. So it will create a delay of 10 millisecond. Okay, now. So that means in order to create a delay of 10 millisecond, we have to load the timer 0 with a value DBFF. DB will be higher, go into the higher byte, and the FF will be going to the lower byte. After just loading this, everything is that now simple is that now we will be checking this one register that is called, we will be setting one register that this is called set the bit of TCON register. This is called the timer control register. We have to set the bit of timer control register. Which bit you want to set? You want to set the bit number 4. This bit number 4 indicates you want to start your timer. This will indicate start or stop the timer. So you want to start the timer? Yes. As soon as you want to start this timer, so you have to set this bit. And this bit in the TCON register is indicate the timer start or stop. Okay, after starting this register, what will happen? After starting this timer, what will happen? It will goes on increasing from the DBFF to so on. First of all, it will go B, from B will go to C, then D, E, F. So that means if I am not wrong, sir, how it will start, I will tell you D, B, F, F. As soon as you will start your timer, now it will go like this. D, B, C, F, F, D, D, F, F, D, E, F, F. D, F, 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 E, F, 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 F. As soon as F, 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 what will happen? 0, 0, 0 will be going. So that means just after F, 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 this will be going to happen. As soon as this will going to happen, what will happen? Overflow flag will be activated. That means overflow flag will be set. So as soon as this overflow flag will be set, your count will stop. Now, this much of operation is basically creating a delay of 10 millisecond. Okay, sir. That means this is very good. So we will be waiting for this overflow. We have to check this flag, overflow flag. So now in order how to check this overflow flag, we have to see. That means decrement, sorry. Just after that, we have to jump on bit is not set. Which bit you are interested? Tcon.5, because this is basically an overflow bit. Then move to the location L1, and this is your L1 location. So now that means we have to go to this, follow this one if the bit is not set. That means we will see if it will go to this, bit is not set. If it is not set, sir, if it is not set, again go to this one. So again it will go to this one, again check, not go, not, if it is not set, this will be going to be happen every time. Now, as soon as the bit is set, as soon as the bit is set, sir, not set means you have to move to the location L1. So as the bit is set, after the bit is set, you have to clear CLR, clear the tcon dot 5. Then we have to look at the decrement, jump on no zero. Sorry, this is not here. Now, this is the only program we are talking about. This is, we have to, at last we know the subroutine program, we have to write RET. This is the program written for creating a delay of 10 millisecond. That means each time you have to see, first of all, it will see this. So this, if suppose you are at this position, what will happen? You will go to this position. Okay. When you go to this position, so what will happen? Is the bit is set? Is the tcon dot 5 bit is set? No, sir. Tcon bits will be set only at this point. So now it will check tcon bits is not set, sir. If it is not set, again it will go to this position. Again it will be decremented, again it will be executed, again it will check the tcon not set, sir. Again it will go not set, set, again not set, not set, not set, not set. Yes, sir, set. As soon as this will come, tcon bit will be set. So if the tcon bit will be set, so it will not repeat this location, it will go to this instruction and it will clear the tcon again, and then it will return to the program. So this program will create a delay of 10 millisecond. Is this clear to all of you? Why to check for tcon.5? Because this is an overflow bit. And this, the meaning of this is the jump on if not bit is not set. And for not bit not set, that means jump to the location L1 if the bit is not set. The meaning of this is that J and B is that jump on the location L1 if bit is not set. So this is the meaning of this instruction. So that means you have to take care of this tcon register as soon as overflow will occur. So this will basically go to this. Now, sir, now let me tell you, sir. Sir, if you load dbFFF, for example, suppose you are loading 0100H. So this will executing, it will take large amount of time, sir. Yes, it is because this program is created to create a delay of 10 millisecond. If you remember, sir, see 1, 2, 3, 4, 5, 6, and 7. So that means while executing this instruction 1 time, 2 time, 3 time, 4 time, 5 times, 6 times, 7 times. In executing this instruction 7 times, the delay is basically getting is 10 millisecond. So we will choose this dbFF as a standard 10 millisecond delay load value into the timer. So what we will do, we will use this standard 10 millisecond delay and we will create a 1 second delay just by changing few line inside the same delay program to provide a delay of 1 second, to provide a delay of 100 second, to provide a delay of 1000 second, and that's all. So that means whatever you do, suppose anyone asks you to provide a delay of 1 second, I will write this same program again. The whole program, this whole 10 millisecond program or 10 millisecond delay program, I will write at once. So have a look. So first of all, what I will do. So I will, yeah, this program is that this. First of all, what we will do, I will load this value, move, listen carefully, move T mod, comma, has 01H, good. Then move this value to the TH0, comma, what value? DB0, DBH, okay. Then we will move this value TL0, comma, has 0 FFH, no problem. Now, after that, we will set this value. Same program I will be writing set B tcon, because tcon register is basically this is to start the timer. So this timer is now started. So we will look on to the time tcon. We will be our eyes will be on the tcon dot 5 register for the overflow. So jump on the bit is not set, jump on the location L1 and the L1 is start here only. Okay. So this will be saying we will keep an eye on the overflow once it is set. So it will move to this. So we have to write this clear and then tcon again dot 5. So this is the program written for the 10 millisecond. So now please look carefully. So now if you have a type program for 10 millisecond, okay. Suppose if you multiply this number with 100, what will happen? So this is nothing but 1000 millisecond. So this is nothing but 1 second. So indirectly you are saying that, sir, if we execute this whole program 100 times, so delay will be automatically 1 second. Yes or no? Please tell me. If this is the program for 10 millisecond delay, if you execute this whole program, if you put this in loop, so this will basically execute 100 times, then automatically the delay will be 1 second. So this is a simple, only 2 line will be written to make this 10 millisecond program to 1 second. Just write this line, move R7. This is the count register. What count you want to put? You want to execute this instruction how many times? 100 times to make it for 1 second. So I will put 100 here and write D. This is the decimal number. So if you know what is the decimal hexadecimal number of 100, you can write here on the H also. But yes, I'm just writing D, decimal value. D is decimal. How many times you have multiplied? We want to execute this program 100 times to make it 1 second, because this program is for 100 millisecond. So now if you have put this register 100 count into the register R7, then you have to look at this instruction, decrement the R7 register and then jump on no zero if the decrement R7 and then jump on the position to the back, and the back position will be starting from here. See, this is the simplest program for the 1 second delay. Now, sir, if you are interested in writing the program for 10 seconds, so no problem, sir. For 10 seconds, we know the program for 10 millisecond. We have to multiply this with 1000. Okay, if you multiply with 1000, what will happen? It will come 10,000 millisecond, and 10,000 millisecond is nothing but 10 seconds. So now we want to execute this program how many times? Not 100 times. We want to execute this program 1000 times. Okay, so instead of loading R7 with 100, we will load with 1000 D. So this will basically execute this program and the delay will be provided by 10 seconds. So depending upon this, we will remember only this program. This is the master program for 10 millisecond. And if in the question or anywhere people will ask, create a delay of 1 second, I will create. Create a delay of 10 second, I will create. Create a delay of 10 second, I will create. That means I will create any delay if anyone, suppose for if anyone asks you, create the delay for 15 seconds. I can create a delay for 15 seconds. Just I need to multiply what value we should multiply, so it will come into 15 seconds. For example, if anyone asks you to create a delay for 15 seconds, okay? We know the program for 10 millisecond. We want to convert into 15 second. Okay. So what value we have to multiply? So we will write like x is equal to 50 divided by 100. Sorry, divided by 10, and this will be 1000. So this will be going, and this see what is the value? Sir, x value is 150. So okay, no problem, sir. We will be loading a count value is equal to 150 D. That's it. No problem. Anything you can do this. So this is the simplest possible way to create a delay. The only thing is that first of all, write use the timer 0 and mode number 1, and then load this value. This value is very important. Please do not forget this value is loaded to provide a delay of 10 millisecond, and then just we have to focus on the tcon.4 register, because this is the meaning of this, to start the timer. And then our eyes will be on this register. This is an overflow bit. So if this is an overflow, if overflow will occur, then only move to this line. Otherwise, repeat this process again and again until and unless the overflow occur. As soon as overflow will occur, then clear this bit again and then return to the main program. See, return to the main program. But if you want to delay of 1 second, 10 second, then just put this whole program inside these two lines. This is this first line. First, put this some value inside the count register, and then look at this condition. This condition says that the meaning of this instruction is decrement jump on no zero. Decrement R7 is having value 100. So first of all, it will go to 99. 99 is not is equal to 0. So it will go to the back button. So again, this process will be continue until unless the day will be 1 second or 10 second. Is this clear to all of you? Is this stuff? Please tell me, is it clear, everyone?
Yes, sir.
Is there any doubt? Single doubt for LCD and LED? Now you can interface LCD, LED. Now you can interface switch also.
Yes, sir, sure.
Because switch is similar, yeah, not a big deal, yeah. If you want to on the switch for how many times, the timer delay will be same only. The LED or switch is same. If you want to on the switch, you can on the switch. How much time you want to on the switch? Your delay will be provided similar. Switch LED will be same only. LCD will be same only. BCD code will be same only. Similarly, keyboards. Now, please tell me. I'm just throwing this concept on you. Suppose anyone asks you to interface keyboard. So the only thing is that, sir, keyboard is also very easy. But in keyboard now, the pin use will be much more as compared to the LCD. There are lots of pin to be required. So out of these port, all mostly all the pin port number will be utilized. This is the only thing. That means if anyone asks you, sir, this is only not tough, but this will be lengthy only. Interfacing keyboard with 8051 is basically a lengthy processor. Only why lengthy, sir? Out of those port, 32 port, we have only 8, 8, 16, 32 ports are there now. Out of those 34 port in LCD, we are using 8 plus 3. That means 11. Total 11 pin we are using. So one port and 3 pin of another port we are using. In case of an LED, we are using only one port, and out of those port, only one bit we are using. And for switch also we are using. But in case of a keyboard, we have to use more number of port. Not only more number of ports, but more number of port within that bit will be used by us. This is the only thing we focus on. Nothing. Okay. Is it clear? Yes or no? Please tell me at least.
Yes, sir.
Good. So now I'm just going to do a recap. Now we'll be discussing tomorrow. Tomorrow we'll be going to discuss how to interface 8086 microprocessor with some of the ICs, that means from 8252 or 8253 or 8255. These are some chips we will be going to interface this, and this is overall for micro. Now your microcontroller part is over. Microcontroller part, nothing is left. Now, in order to interface keyboard, we can give the question from keyboard interfacing, but it is very lengthy. So you can do this. I know everyone can do this if you know the how to interface LCD, how to interface LED, how to interface these things. So you can do the interfacing of keyboard, but the only thing is that this will be somewhat lengthier as compared to this one. Okay. So now I'm just going to do a quick recap for you all so that you will not get confused. This is called the concept recap. Have a look, sir. In this part, we are talking about LED. We are talking about switch interfacing. In this case, we are talking about LCD. Okay. What are the most important thing we remember? In this case, T0, T7 pin will be required, as well as one resistor select, one read write pin, and one enable pin will be required. And two pins are there, VCC and VSS. This will be ground, and this will be plus 5 volt is required. In switch and this case also, one VCC will be required definitely. Sorry, No VCC is required because VCC is given from that power supply. Only one pin is required. This is VSS and this is plug ground. And the other pin is required. Only one pin is required. This we got and called an output. So that means this pin is required. And in this case, 1, 2, 3, 4, 5, 6, 7 pin is there given. And out of this, one is RS. This is C. These pins are required. So total, how many pins are required? 8 to 8 plus 3. That means 11 pins are basically connected or need to be connected to the 8051 microcontroller. Okay. In this case, only one pins are there, sir. So this one pin is need to be connected with the 8051 microcontroller. Okay, sir. Now, in this, out of these 8 pins, we are connecting the port number 2. Port number 2, all the 8 pins we are connecting with the D0 to D7, sir. And out of this port number 1, we are connecting 3 pins. That means pin number 1.0 and pin number 1.1 and pin number port number 1 2.2. This we are connecting with RS. We are connecting with this read and write bar, and this we are connecting with the enable. That's it. In this case, sir, we will be connecting the port number 2 and the bit number we can use, or we can use port number 0. Only one port we can use, and then port number 2 we can use port number 2 1 also. But it is an ideal method, or it is a good practice to use whole port. Sir, we will be using whole port. Okay, we will be converting whole port. In that whole port, we will be connecting 8 LEDs. We will assume that we have connected 8 LEDs. If you don't want to use that LED, put the value 0 there. But if you want to use those LED, you can use. For example, I will be using 8 LEDs. So we will be using 8 LEDs. So we will connect 8 pins. 1, 2, 3, 4, 5, 6, 7, 8 LEDs we are connecting. LED number 1, LED number 2, and so on. We are connecting LED number 7. So 0 to 7, 8 LEDs we are connecting. But sir, in this portion, we are interested in only 3 LED. If you are interested in only 3 LED, so make this LED as, suppose this is an red, this is an yellow. Suppose this is an LED 3 is basically your green. So we are interested in only 3 LED. We are not interested in this LED. So please remove this, put this value 000 on it. So this LED will not be create any problem. It will be there only, but it will not create any problem. So now these are the LED. So we can connect this LED. Either you can connect red, yellow, green here, or you can connect any port you can want. So now if you have connected this red LED and a green LED, Y LED, and so on, you have so many LEDs. So suppose you have connected this port number 2 to dot number 7, port number 2, 6, port number 2, 5. So we will be dealing with this one. We can on this all the LED one time. We can off this LED all the time, or we can do one thing. We can on this LED 1 and this will be off, or we can do this, which is will on, this will be 0, or we can do this 001. For example, in traffic light. So this is the 3 case. So we need these 3 cases. So we have to load this value first into accumulator, and then we have to create a delay. Then we have to provide a delay. We have to load this value into the accumulator. Then we can write a delay program. And then we have to load this value inside that. We have to load the delay program here. So if the all the delay for suppose we want to glow the red light for 10 millisecond. If you want to glow the green light for the 10 millisecond, and again, if you want to glow this light for 10 millisecond, no problem. Write as one subroutine program only and call those program every time when you load this value into the accumulator. Now, if you want to glow these red, green, and yellow light for different amount of time. So, for example, this we want to glow for 10 millisecond. If you want to glow this for 1 second, and if you want to glow this light for 10 seconds, so then you have to create a 3 delay program: delay 1, delay 2, and delay 3. So write delay 1, delay 2, delay 3, and then loading this value, and then call the delay 1, loading this value and call the delay 2, loading this value and then call the delay 3. That's it. This is the simplest way to create a traffic light. Or example, suppose if anyone asks you, come to you, and then you will sort that, sir, please, I have an 8 LED. Okay, so 7, 6, 5, 4, 3, 2, 1, 0. So if I am at 1 LED, so I want to flash my LEDs on and off. So okay, 1, 1, 1, 1, 1, 1, 1, load the value FF, and then 0, 0, 0, 0, 0, 0, 0, 0, that is 0, 0 H of the LED. On the LED for 10 seconds. of the LED for 10 seconds. That's it. That is flashing of LED. LED will flash 111. It will be on for 10 seconds. It will be off for second. This is called blinking of LED. Just by loading this and then creating a delay. Just loading this, creating delay. So now have you another question we want, sir? We don't want this situation, sir. We want this one. 1 1 1 0 0 0 0 0 1 1 1 1 1 1. This is the case. Suppose we want to flash this line and I on of this line in the second for 10 seconds. For 10 seconds, I want this situation, and for another 10 seconds, I want this situation. So we can load this value and then create a delay and then call a delay, and we can load this value and then we can call a delay. So depending upon this, we can do this program. Any value you can do, any time, any situation. Suppose another question number 3. Now suppose the question is that we want to group alternate LED. That means 1 0 1 0 1 0 1 0. So this is called A and this is called A. So we have to load AA value into the accumulator, and this accumulator we have to go to the port number 2. Now what will happen again? For how many time you want to create this? I want to do this for 10 seconds. Okay. Then after that I want to blow this alternate. This will be 0. This will be 1. This will be 0. This will be 1. This will be 0. This will be 1. This will be 0. This will be 0. This is the alternate arrangement. So this is basically 5 and this is basically 5. So you have to load 5H inside the accumulator, and then the accumulator will go to the port number 2, and then we have to call the delay. What delay? Suppose this is also 10 seconds. So you can call this delay after this. So this LED will be, this will be on and off. This will be off and on. This will be on and off. This will be off and off. This is so many question and so many approach you can come through. You can do any question. Suppose LED based any question is coming. Now you are in a comfortable position to any programming. And not only this will helpful here, but it will be helpful in the programming part when you will be using the embedded system now. Then you will remember my name at least. Sir, Deep sir has already told this how to load some values, how to do the linking up with the microcontroller only, how to interface the LCD, how to display some messages. Because what I feel personally now, when I taught some student now from the 4th year only, they don't even know these things basics. They don't know how to interface these things. They don't know how to interface Arduino Uno board only. So this will be helpful to interfacing Arduino Uno board with the LED and LCD if you know these concept, if you know the concept of this, which I have already taken on. What value you need to know, how to load this, how to interface this. If you interface any device, what are the parameters you look for? These are the some basics we must know. Is it clear to all of you? Yes or no? Please tell me yes or no. Yes,